Hello, everybody. Okay, I'm just doing the back side of our review. This is the Unit 4 review, and you can do the front side. You can just look at the front side, and you can just look at the answer key. Okay, I'm just going to give you a heads up. Behind me in the next room, there is the UIL All-City Band Competition or practice, and you're going to hear music throughout. This is a lot of fun. Okay, so problem number 15. Remember, when I'm solving inequalities, it's just like solving equations. I've got to make sure both sides are simplified, check and see if the variables are on both sides. If they are, I got to get them to one side, and then I solve. The only difference is that I have to remember that if I multiply or divide by a negative, I flip the inequality. Well, you were waiting for that siren, weren't you? Okay, so let's check and see if both sides are simplified. No, my left side's not simplified, so let's do that. I'm going to have, let's see, first I'm going to leave to change the whole thing. Okay, so I end up with 20x plus 4 times negative 3, distribute correctly, is negative 12, is greater than 17x plus negative 9. Now, are the variables on both sides? Yeah, they are. Ooh, I want them on the same side. So let's find the one with the smaller coefficient. That's 17x, and let's get rid of him. So let's subtract 17x from both sides. And I'm going to end up with 3x plus negative 12 is greater than negative 9. Remember, I subtracted my smaller one because I wanted to end up with a positive coefficient right here. It makes life easier for me, so I don't have to worry about flipping. So now I'm going to add 12 to both sides. And I end up with 3x is greater than 3. I'm going to divide both sides by 3. And I get x is greater than 1. Let me graph that. So greater than, so that doesn't include 1. I just want all the numbers in that number line that are greater than 1. And there you go. Okay. Let's go to the next one. Oh, wow. I'm going to have to simplify this puppy, that's for sure. Let's see. So I'm going to leave change. That's about it. So I end up with 4x plus, distribute correctly, 2x plus negative 6 is less than 2x plus 12 plus x. Okay, so I've leave change, distributed. Now I've got to combine like terms if I can. And I can. I'm going to combine the 4x and the 2x. So it's going to give me 6x plus negative 6 is less than, I can combine the 2x and the, there's no number in front of that 1. If there's nothing, then you better put a 1 on it. Okay, so it's going to be 3x plus 12. Now, are there variables on both sides? Yeah, let me get them to one side. I subtract 3x, and that gives me negative 6 is less than, that gives me 3x plus negative 6 is less than 12. So let's add 6 to both sides, and I get 3x is less than 18. Divide by 3, and x is less than 6. So that looks like this. Less than. Okay, it's not shaded, it's open because it doesn't include 6. I want all the values in the number line. We can raise our hand and say, I am less than 6. And that is all of these. Okay, great. Okay. Ooh, I love this kind of problem. So let's simplify this. So let's leave change. What am I going to put there? A negative 1. Very good. So let's say I end up with, I'm going to distribute now. Negative 5x plus, distribute correctly, plus 3. Positive 3. Negative 1 times negative 3 is positive 3. Is greater than negative 1. Let me combine like terms. Oh, we'll put a 1 there. So I'm going to get negative 4x plus 3 is greater than negative 1. Okay, now I'm going to subtract 3. Negative 4x is greater than negative 4. Okay, now I'm going to divide by negative 4. Oh my gosh, I'm getting excited. I'm divided by negative. Woo! So what do? I'm going to flip the inequality. X is less than 1. I'm done. So I'll do 0, 1, 2, less than 1. A lot of these, don't I? All of these are on the small side of 1. 1 is bigger than all my values. I'm actually going to check this for fun, I think. Okay, so I'm going to pick a value that I said was true. I'm going to pick 0. That's an easy one. I'm going to stick it in my original equation. So I have 0 minus 5 times 0 minus 3 should be greater than negative 1. So let me see. 5 times 0 is 0. 0 minus 3 is negative 3. So 0 minus negative 3 should be greater than negative 1. I did the stuff in the parentheses first because that's what PEMDAS tells me to do. Okay, now I know this is leave chain change. It becomes plus. So 3 is greater than negative 1. Is that true? It's true. That means I shaded the correct side of my endpoint. Oh, I like this kind of problem. All right, so now I have some kind of a polynomial on top of a denominator. And the easiest way to solve this is to multiply both sides by 2. Because when I do that, I can actually divide out the 2 and the 2. And all I'm left with on this left side is x plus 35. That's all x plus 35 is less than or equal to 50. And that's easy. I can solve that. So I'm going to subtract 35 from both sides. And I'm going to get x is less than or equal to 15. So less than or equal to, oh, got to include 15. It's closed. And everything that's less than or equal to it. Okay. Let's go to the next one. Jamie wants to do at least 50 push-ups. Ooh, I like that at least number. So whatever I'm going to come up with, it's going to have to be at least 50. If I know that this is what 50 looks like, at least 50 is going to be 50 or more. So whatever it is going to be greater than or equal to 50. I don't know what that is yet, but I know that's what I'm going for. She's done 28 already. So that's, I'm starting with 28. Write and solve an inequality to find the number of push-ups she needs to do. So let's call it, what do you guys want to call it? P. That's going to be my number of push-ups that she still needs to do. So I know she's done 28, and then she's going to do some more. So I'm going to add that to 28, and that's going to have to give me greater than or equal to, it's going to be more than or equal to 50. That's my inequality. So to solve it, I subtract 28, and I end up with P is greater than or equal to 22. So as long as she's done at least 22 push-ups, then she has reached her goal. So she could do 30 and she still reached her goal. So I'll call this 22. And she can do 22 and reach her goal, and more. Anything greater than 22, or equal to 22. Okay. Next. All right, Jared wants to receive a B in his math class. Dude, he's done all of his homework and done well on this quiz. It's very good. That gives him some leeway. So he only needs an average of 72 on his tests to make a B in the class. So what I'm looking for is I'm trying to find an average of 72. On his first test, he made a 65. On his second test, he made a 77. And I don't know what he made. Well, I don't know what he's going to make on his third test. Let's try to figure out what he needs to make. Define the variable, then write, solve, and graph an inequality for the grade he needs to make on his third test. So what am I looking for? What's my variable? Whatever that grade is that he needs to make. What should we call it? Do I call it G? I'll call that the grade he needs to make. The grade on his third test. Okay. Now we're talking about an average, and he's taking 3 tests. So the first test he made a 65. And I'm going to add the second test where he made a 77. And I'm going to add the third test. Oh, I don't know what that is yet. That's my variable G. Okay. And once I get all those things, I'm going to divide them by how many? 1, 2, 3. I'm going to divide it by 3. That's what the average is. And I'm looking for a number that is 72 or more, right? I want that number to be greater than or equal to 72. Hey, if his average is 78, awesome. He at least makes his B, so that's good. So here we go. Now I've got to solve it. So that's my inequality. And how do I solve this thing? Well, if I multiply both sides by 3, so those 3's are going to divide out, and I'm left with something really simple. I'm left with 65 plus 77 plus G is greater than or equal to 216. That's what that ends up being. Okay. So now I've got to just simplify. So that means I'm going to combine like terms here. So that's going to be what? 142? I'll subtract 142. And I'll get G is greater than or equal to, it's a 4, and that's a 7. There we go. Okay, cool. So the grade he's got to get on this next test has got to be greater than or equal to 74. If he does, he's met his goal. So here's 74. It could be 74. He'll still meet his goal. And everything above it. G is greater than or equal to 74. All right, Joey's saving up for a racing bike that costs $920. Ooh, that's going to be important. He has $400 already saved. He's saving $50 a month. How many months does he need to save before he has enough money to buy the bike? My question is, how many months? So what do you think my variable is going to be? Let's call it M for months. Okay, that's the number. It's really the number of months. Number of months he needs to save. So let's see. How much money does he have to have? Let's see. Well, he's got to have $920. Could he have $915? Would that be okay? No. Could he save like $950 and be able to buy it? Yeah. So as long as the amount of money that he saves is at least $920, then he's good to go. So remember, at least means it's got to be greater than or equal to 920. That's what I'm going for on my graph, right? This is 920, and I could get 920. That would be good, and if I got more, that would also be good. Okay, so it's greater than or equal to 920. So he already has $400. Oh, so let me write that down. Something is going to be greater than or equal to 920. He already has 400, and I'm going to add to it. $50 a month. How do I say $50 per month? It's going to be $50 times the number of months that he saves, right? So here we go. Let's go ahead and solve it. Oh, this is great. And I end up with 50. M is greater than or equal to 520. Okay, all right, that's fine. divide by 50, divide by 50, and I get m is greater than or equal to 10.4. Okay, so after 10.4 months, or at 10.4 months, he's got enough money. But the question, months is, we're not going to count those in like partial months, because he's going to kind of put all of his money in the end of the month there. So after 10 months, will he have enough money? No, he won't have enough money after 10 months. What about after 11 months? Will he have enough money? Yes. So just by thinking about what the question is saying, the answer is that when it says how many months does he need to save, he needs to save any number of months that is greater than or equal to, really, well, it's 10.4, where m is an integer or a whole number. So if you wanted to say this, you could say m is greater than or equal to 11, really, because after 11 months, then he's good to go. So if this is 10, not enough there. This is 11. Yeah, he could say for 11 months that would work. That would work. If he stays for 13 months, would he have enough? Yep. Any number of months after that would work. Okay? But it's important to know that 10 months would not work. 10 months would not work. It's got to stay for at least 11 months. All right, Maxine's sink is clogged. She's called 2 plumbers. This is a bonus question, by the way. It's not on your review, but this will help you, I promise you, on your test. Thank you for listening to the review. Thank you for flying the friendly skies. Maxine's sink is clogged. She's called 2 plumbers. Now we got plumber A, and he's going to charge $50 to come to her house, plus $30 per hour to fix the sink. Okay. And plumber B, he's going to charge, he's just going to flat rate at $240. Okay, let's define a variable and write, solve, and graph an inequality to find the amount of time that plumber A is cheaper than plumber B. Since I drew all over the words, I'm taking them off. Goodbye. Okay, but I'll just do plumber A in red, and I'll do plumber B in blue. Okay, so define a variable, then write, solve, and graph an inequality to find the amount of time that A is cheaper than B. Okay, so I'm looking for the number of hours. Okay, so I'll say variable is H is hours. And because they charge for the hour. And if you work a partial amount, then guess what? They charge you for the whole hour. So like if they work 20 minutes, sorry, you get charged for an hour. Let's see. Okay, so define a variable. So I've called that H, right? And I'm looking for the amount of time that plumber A, is cheaper, it's going to be less than plumber B. So let's see. So I'm going to write something where A is less than B. Okay, here we go. So what is A? He's going to charge $50 just to come out, and then $30 per hour. So I'm going to represent that as $50 plus $30 per hour. And plumber B charges $240. Doesn't matter how long the time. All right, cool. So now let's just, that's cool. All I'm going to do is solve. I'll do it in rain. So I'm going to subtract 50 from both sides. And I end up with 30H is less than 190. And that's not going to divide evenly, but it doesn't matter. So divided by 30, divided by 30. Where's my line? And I end up with H is less than 6.3333333, which is the same thing as 6 1/3, which is the same thing as 6 hours and 20 minutes. Yeah, that's right. Okay, so if the job is 6 hours long, okay, then who's going to be cheaper, A or B? Plumber A is going to be cheaper. Anything that's less than 6.3 is going to be cheaper for plumber A. What if the job is 7 hours long? Who's going to be cheaper? Plumber B. Plumber B is going to be cheaper. So how would I graph that? Let's see. So I'll call this 6, 7, 8, 5. And since they charge for the hour, it's kind of like an hourly rate, we'll just pick the hours that are less than 6.3. So this is 1, this is 1, this is 1, and this is 1. Okay, and all the way down to 0. Okay. Because if it was 0 hours, if they just show up, plumber A would still be cheaper because plumber B would cost $240. If they actually charge by the minute, if that were the case, if they actually charge by the minute, then the way I would graph this would be I would find 6.3, yeah, 6, which is kind of what I'll say is right there. 6.3, and I'll make a big open circle, and I'll choose everything that's to the left of 6.3. Now at 6.3, that's when the prices would be equivalent. That's when they would be equal. Right now we're looking for when A is cheaper. Okay, good job, guys. Good job. I hope you understand. And I look forward to grading your tests. I'm sure you will rock them. Good luck studying. Hope you enjoy the musical accompaniment.